I am Brooks Robertson. This is my colleague, Alex, and we're going to talk a little bit about open data and how we built it. So, operations is a pretty deep topic and concept. There's a lot of terminology. It's a mile wide, mile deep. We can go through all these kind of different concepts and ideas, but I think what we really want to do with the time we have is scale it back a little bit. So instead of kind of proselytizing and going into deep philosophical discussions or ideas around how you should do ops, we'll talk about what our experience was building out open data over the last 3 years. By the way, do you guys know who this is? It's Socrates. He's about to drink poison. Hemlock, don't do that. It'll get better. Ops will get better. All right, so, there we go. So, all the way back in 2014, we launched open data. We started with pretty simple AWS stack. We utilized OpsWorks, which is just a web interface client that you use to manage your Elasticsearch. Not Elasticsearch, but your EC2, some of your security groups, things like that. It obfuscates a lot of the details related to that. But at the time, it was great for us because we didn't have the kind of experience and knowledge with some of the more complex stuff within AWS. So it's a really good fit. So moving on to our application stack, it was pretty simple. We had one large Rails repo. It contained our front-end apps, our assets, everything. And we also had an app called Coop, which is a Node app. But this was our kind of whole stable of application layer. However, in the Rails app, there was a lot in there, a lot going on. So we had an API, we had client apps, as I mentioned, asset delivery, harvesting, routing, data persistence, business logic, and also it managed the search index, Elasticsearch. So it's a lot of stuff. So we were able to get it out, and we were now servicing customers, but we were starting to run into some issues. The single project structure in the Rails was kind of a blessing and a curse. The project, it's one thing, so it's easy to deploy, it's compact, you know the dependencies, but there's also other aspects that really made it problematic. As the previous slide was illustrating, it's a big bucket of stuff, and you're really mashing all these different concerns in together, and there's no kind of division of labor. So it's just hard to manage. And a byproduct of having all these things in the same place was that really features that were unrelated got blocked. You may have something that's ready to go, but it's behind another feature that hasn't been completed. But they're all in the same code base, and unintended dependencies. So, through this process, we said, man, we want to move faster. How do we do that? We have this big monorail, and we want to be able to split these different things out. So we started talking about microservices. Microservice is something that is a very focused and easier to maintain piece of code. It does one thing and it's separated from everything else. In our case, we use primarily Ruby and JavaScript, But if you build the microservice and have a common interface, it doesn't matter what the language is on the inside. We're talking JSON. And it can be deployed independently. So we went down the road of starting to split out these different pieces. We went from Rails and Node to an Angular app client, a Backbone app client, another Node.js, and we also introduced S3, which was storage for those client apps and where they got deployed from. So microservices get put in place. We start moving faster. You can run in parallel. It's great. Kind of. The magical unicorn doesn't look as kind of sweet as we anticipated. It looks like a child drew it. A child probably did draw this. Got a Snoopy head and an ice cream cone on its head, and it's not all that great. So we were successful in, as I said, speeding up development, but we were bottlenecked in other places. And the reason we were bottlenecked in those places is we had all these now separate resources and microservices, but we didn't really have a cogent way to put those things all back together. And how do we test those things? We're testing them in isolation, unit tests, and we did a good job with that. But when you roll all these things out, the endpoints aren't quite matching up. So we're speeding along with all these different microservices really fast, trying to get it into production, and it's just slowing down, and it's not working. So we spent all this time, but we're not realizing really the results that we wanted. We want to move faster, and that includes moving not only from the development environments to QA, but also to production. Because the end goal is not just to move fast, to be moving fast, but to get these features out in front of customers. So another kind of unintended consequence of doing microservices was we had this really dense application that was very complex, and that complexity didn't really go anywhere. It just got spread around. And as that complexity got spread around, we were also moving it. And we were moving it further away from the developers and putting it on really operations. So you now have a person that didn't develop the app and doesn't necessarily know the functionality being responsible for maintaining it. Our ops guy isn't here, but he's a great guy, and we did this to him. So don't do this to your ops guy. This gets us to about middle of last year, 2016. We've been having releases, and we're working through and moving these things into microservices. But we've reached a point of kind of entropy. We can't do it anymore. It's really expensive. Not only the release of code, but the maintenance of code that's already in production is really expensive, and we've got to figure out something else. So at this point, this is where I'm going to hand it off to Alex, and he's going to kind of give you what the last 6 months has been about.
All right, can everybody hear me? All right, so first thing we did was throw more people at the problem. So we formed the kind of ops super squad, which included me, and we had sort of two primary problems that we're trying to solve. One is, we have this bottleneck in getting code to production, so we need to figure out why all the code changes are kind of stacking up in QA and not making it out to production where people can actually use it. The other big problem we had was we had, just production incidents that were happening at the most inopportune times, like when we were sleeping or when we're really focused on something, and then all of a sudden, Elasticsearch is having troubles, or there's some sort of unplanned for incident. So those production incidents were sort of chewing a lot of time and were disrupting our team's ability to schedule, to create a product timeline. So now that we got sort of three OPSI nerds together, instead of diving straight into like let's stand up a Jenkins CI server or do auto scaling groups, we kind of had to take a step back and think about what are sort of the deeper issues at the team level that are causing these problems. So we read a few things related to ops and DevOps culture in general, and we came away with some sort of key concepts. So the first collection of these concepts, I call them types of work. So they are simply business value, internal value, changes, and unplanned. So business value is good. It's the stuff that pays your team and keeps the lights on. And if you're spending a lot of time on this category of work, your team is doing well. Internal value is also good. Internal value is, a customer is not going to pay you for this kind of work. So a good example would be, again, a continuous integration server that will allow your team to move much faster and more confidently, but no customer is going to pay you because you have a Jenkins CI server in your closet. This is sort of entirely internal to the team. The third category, changes, is just kind of like just a cost of doing software in general. These include things like configuration updates or sort of routine maintenance tasks, database upgrades or security patches, things that you just have to do. But if you can, you want to try to minimize the amount of time you spend in this category of work. And the final category of work is unplanned work. So this is terrible. It'll destroy your team. It'll just ruin your timelines. It'll disrupt your sleep schedules. It's in every way just unambiguously bad. And the second collection of concepts we sort of centered on, I call them phases. So the sort of phases of ops maturity. And in phase one, it's called stabilize the patient. So the idea is you identify the highest risk changes that your team has to routinely make, and you also try to identify the causes of production outages. So stabilize the patient is sort of a self-explanatory phase. Second phase is called catch and release. So what this is centered on is finding the parts of your infrastructure that have the highest failure costs and that are hard to replace or to make any changes to. The third main category is called establish a repeatable build library. So it's kind of a lot of words, but what it basically means is make your infrastructure standardized and make it cheap to recreate. So you might get into a situation where you lose an entire piece of your infrastructure. If you've achieved this sort of phase of ops maturity, it's actually cheaper to just recreate a part of your infrastructure from scratch than it is to try to manually edit JSON files in Amazon. And the fourth phase is enable continuous improvement. So this is where a lot of ops talks begin. They show off the Jenkins CI and the fancy pipelines and stuff. But this is sort of the final stage of ops maturity. And so this is when you begin to use your infrastructure to provide feedback to the team as fast as possible. So this is where you have automated testing that tells a developer that they've broken something before they've even pushed their code to any remote environments. It could also include things like performance tests that are scheduled every midnight. So you can know if you're proposing changes in the application that might adversely affect performance. So now that we had these concepts, we wanted to apply them to our highest priority tasks. So our number one priority was we had to get rid of these, we had to at least reduce the number of production incidents we were facing. And, as explained before, it was causing a lot of unplanned work. So this was step one was just put out the fire. Step two was we had all these fragile infrastructure configurations. So over time, our dev, QA, and production environments began to diverge. because they were not in any sort of version control, and it made it really hard to make any changes to any environment ever. And it also made sure that even if we tested something in QA, we were not 100% sure that it would work in production because the configurations were slightly different. So there's always a little bit of uncertainty even after we had thoroughly QA'd something. The third sort of main task we wanted to take on was our release cycles started to become more unpredictable in that they became longer and longer. And the big problem was that because changes were harder to make, as in deploying code to production, deploy windows become scarcer and scarcer, which actually influence developer behavior. So if you know that the next deploy window might be 3 months from now, you're more likely to try to shove in as many changes as you can to meet the current deadline than you are to just wait until the next one. So we had to do something about that. And then the final category, or the final sort of task we wanted to take on, was that bugs were being found too late in the cycle. So in many cases, they were found in production or in QA, but the cheapest place to find a bug is on a developer's laptop. It hasn't even hit a remote environment, and it's very easy to implement the fix there. So we wanted to basically push the bug discovery process further and further up the chain until it was mostly done at the developer laptop level. So one of the first things we did as the ops squad was implement the support engineer program. So we developed what we called playbooks. So these were basically step-by-step guides that corresponded to common failure scenarios. So a application owner, i.e. the person who understood an application the most, would actually write down, here are the steps to do should X scenario come up. And that way, it doesn't have to live in that developer's head, that anybody who has access to the playbook can actually just implement the steps. The second major part was we started implementing on-call rotations. So instead of having our poor ops person respond to everything all the time, we started rotating that duty. So now there were 3 of us in the rotation. And because we had access to these playbooks, we would just kind of pull them up when an incident happened and put the playbook in action. If it was a truly special incident, like it was just, some weird networking outage or we've never seen this before, then we would escalate to our ops person. So it kind of provided a layer of buffering. And the final thing was actually more informal, but I think was equally important, which was that it started changing team incentives. So now that application owners were in the on-call rotation, they started developing their applications in such a way where they would be more resilient in a production environment. And this is sort of baked into the development process from the very beginning, because once every 3 weeks, it's going to be your turn to be on call 24/7 to respond to production outages. So the incentives are now aligned for you to consider that as like a first level concern when developing an application. The second big project we did was we started putting our infrastructure in version control. We used Terraform, which is a tool developed and maintained by HashiCorp, and it's used for programmatically managing and provisioning infrastructure. So it's open source. You can go to it at GitHub, and what it allowed us to do was once we wrote down all of our infrastructure configurations, we were then able to recreate entire environments basically at will. We could also run tasks that would tell us which resources we're modifying if we made any changes to our Terraform repo. It's a really, really neat tool. Finally, we had, in order to address the release cycle problem, we basically designated a release manager, and we also committed to a weekly deploy window. So we said, I know normally we've been doing 3-month deploys, but we're going to force our team to work with a weekly deploy window, and we're going to make it one person's primary responsibility to make sure that the release goes well. And what that basically ended up doing was that release managers would impose constraints on developers, and so it actually ended up making the process a lot smoother. And the sort of last primary thing that we did, this was sort of a team-wide, not purely an ops squad thing, was we sort of had a new QA process. So instead of having one person test everything, we started distributing testing responsibilities more evenly. So that led to some good outcomes. One of the biggest ones is that more and more people knew how to test things effectively. And also that freed up our QA engineer to dedicate more time to automating the high value tests. So we began to protect the most valuable parts of our application in an automated way. We also developed an internal tool called Open Data Docker, which used Docker Compose. And what that allowed a developer to do was to pull down this repo and to stand up a full production-like stack on their laptop. And so it actually ended up being used primarily as a QA tool in the beginning. Certainly I used it that way, where I would pull down someone's latest changes, build a bunch of Docker containers, and run the entire app in a production-like setting so I could offer early feedback on a feature against an environment that looked a lot like production. And so to kind of review the problems that we had, we had these intermittent production outages. So we implemented the support engineer program as sort of a first step to stabilize the patient. We had these fragile infrastructure configurations. And so we used Terraform to put them in code and to turn these fragile artifacts into repeatable builds so we could, again, recreate them at will. We also had the issue of unpredictable release cycles. So we committed to weekly deploy windows and tasked a release manager with ensuring that the release went well. And finally, with the issue for finding bugs late in the dev cycle, we distributed our QA responsibilities, and we started using Docker more aggressively to test work in progress code in a production-like environment. There's some other sort of general lessons that we learned that don't fit into any of the categories discussed previously. One is that humans forget things, so write them down, put them in version control. This is a good practice for just about anything. We put our playbooks in version control. You could put configurations in version control, put notes, just write it down. You won't regret it. Another thing too is that you can change team incentives to solve problems. So instead of reaching immediately for, we're going to build this really fancy CI system and it's going to be great and awesome, just align the team incentives in a new way. So one example of that is the release management cycle. So every week, a release manager would be tasked with ensuring that the release went well, and the duty would rotate from time to time. And so what generally happened was that each new person that was responsible for that week's release, they would sort of bring a new set of experiences and knowledge and understanding to the process. So they would kind of take the process from the previous release management cycles and add new constraints or alter them, or in some way improve the release cycle. And kind of related to that is, before implementing a technological solution, see if you can improve a team process. So it's cheaper. You don't sort of lock yourself or overcommit yourself to any particular ecosystem. And it's a lot easier to get feedback because you can just ask people, hey, did it go well? Did it not go well? How can we improve it? So these are some of the resources that I mentioned. The two books that we kind of got these concepts from called the Visible Ops Handbook and the Phoenix Project. You can read them, they're good. You can also read summaries of them and get sort of an actionable understanding of the core concepts. So if you don't want to actually read the whole thing, you have my permission to go to their Wikipedia pages and say you have. The other two sort of big tools that I brought up were Terraform and Docker Compose. And again, they have websites, GitHub pages, and I highly recommend checking them out. And yeah, I mean, this is sort of the high-level overview, the story of the ops behind ArcGIS Open Data. And at this point, I'd like to open up for questions or comments or sort of anything from the audience. Or rounds of applause.